Let's talk about the IUPAC nomenclature of alkenes and alkynes. So following our steps, the first thing to look at is functional group. In the case of alkenes and alkynes, there is no functional group present, so we do not use this step. Then we move on to the next one, which is carbon-carbon double bond or carbon-carbon triple bond. So in case of alkene, you will find carbon-carbon double bond, and in case of alkynes, you will find carbon-carbon triple bond. This is the step from which we will start when naming the alkenes and alkynes. The step 1 and step 2 decide the suffix part of the name. Since there is no functional group present, so the name will end with an E, and if alkene is present, then we will add EN, and if alkyne is present, then we will add YN. The third step is to find the parent chain. A parent chain will be the longest chain that will contain the carbon-carbon double bond or the carbon-carbon triple bond. That is, the double bond or triple bond will be part of the parent chain. And as for the substituents, they will be the alkyl groups. Alright, so let's look at some examples. The first one is an unbranched alkene. How do we know this is an alkene? Because there is a carbon-carbon double bond present at this spot. Since there is no functional group, the name will end in an E, and as there is a double bond, so it will also have EN. That is the suffix of this name. Now let's find out the parent chain. If you number from left to right, you will see that the carbon-carbon double bond is present between carbon atom 2 and carbon atom 3, and the length of the parent chain is 6 carbon atoms. If you number from right to left, the carbon-carbon double bond will be present between carbon atom 4 and carbon atom 5. So which one will we pick? We will use the lowest locant rule, and so we will number from left to right. Now we will pick that carbon atom from which the double bond is beginning, which is the second carbon atom. So the position of this double bond is 2, and the length of the parent chain is 6. So the name of this compound is hex-2-ene. You can also write this as 2-hexene. This is also a valid name, but I prefer to write it this way because it tells you exactly what is the position of the double bond. Alright, let's look at an example where there is one substituent present. What do you think the name of this compound will be? Start with finding the carbon-carbon double bond or triple bond. We can see one carbon-carbon double bond here. Now find the parent chain. You can see that we can take either this as the parent chain, or we can go this way. Both of them have the same length and the same number of substituent, so we can pick either one. I will stick with the straight chain. Alright, so we can see that there is a methyl group present as a substituent here. Let's start naming now. So numbering from the left to right, we can see that the length of the chain is 5 carbon atoms, and numbering from right to left, we will see that the double bond can be written as either at position 2 from the left or position 3 from the right. We will pick the lower number. So the name of this compound will be, for 5 carbon atoms, it will be pent. The position will be 2 for the double bond and ene. Now there is a methyl group present at the second carbon because we are numbering from the left to the right. So at the second carbon there is a methyl group present. So we will write 2-methyl pent-2-ene. What if we have multiple substituents? As in this example, can you try to write the name of this compound? Again, there is no functional group, so it will have an E at the end, and we can see there is a carbon-carbon double bond, so it will have En at the end. Now we need to find out the parent chain. The parent chain for this compound is this. You could also go to the top or to the bottom, but both of them are of the same length as this one. Now let's find the positions of the substituents and the carbon-carbon double bond. If you number from left to right, the double bond will be at carbon atom 2 and the substituent will be at carbon atom 5. And if you number from right to left, the substituents will be at carbon atom 2 and the double bond will be at carbon atom 4 from right to left and from left to right. So now which one will we pick? We cannot blindly use the lowest locant rule here because there is a preference. When deciding from which side we should name, we should try to keep the position of the double bond as the lower number. Alright, so the priority is double bond holds priority over the substituent. Okay, so we will pick the direction from left to right. So we can see that the double bond is starting at carbon atom 2, so it will be 2-ene and there are 6 carbon atoms, so hex 2-ene. Now there are 2 substituents present and both of them are at carbon atom 5, so we will write 5,5 dimethyl because there are 2 substituents. So the name of the compound is 5,5 dimethyl hex 2-ene. Let's move on to the next one. We now have an interesting case where we have more than one carbon-carbon double bond present in the compound. Now in this example, you can see that there is no branching. So this is our parent chain and it has 4 carbon atoms. If we start from left, we can see that the first double bond starts at carbon atom 1 and the second double bond starts at carbon atom 3. If we move from right to left, we can see that the first, from this direction, the first double bond is at carbon atom 1 and the second double bond is at carbon atom 3. So whether you go from left to right or right to left, in this example the positions are the same, so you can choose any one. Now the length of the parent chain is 4 carbon atoms, so we can write but, some people write buta. Okay, then we have 2 double bonds. One is at carbon atom 1 and the other one is at carbon atom 3. So buta 1, 3, then diene because there are 2 carbon atoms. So this is the name of this compound. Alright, Let's look at this other example. Here also we have two carbon-carbon double bonds. Now let's first identify the parent chain properly. This straight chain has 4 carbon atoms. Also, if you move from this one, it also has 4 carbon atoms. So can we pick any one of those as the parent chain? The answer is no. And why? Because at the start we discussed that when there is carbon-carbon double bond present, then the parent chain will be the longest chain that contains the double bond, or the double bond needs to be part of the parent chain. This is not possible if you select the parent chain like this. This carbon atom will become a substituent. Therefore, there is only one parent chain possible here, and that is the straight chain. Alright, now let's number this parent chain. If you number from left to right, you will see that the first double bond starts at carbon atom 1 and the second double bond starts at carbon atom 3. There is also the substituent which will be present at carbon atom 2. If you number from right to left, then you will see that the first double bond starts at carbon atom 1 and the second double bond starts at carbon atom 3, but the substituent in this case will also be found at carbon atom 3. So which one will we choose? We will choose the lower number, and so we will number from left to right. Now writing the name of this compound, there are 4 carbon atoms in the chain, so it is buta. Then double bonds are present at carbon atom 1 and 3, so 1,3-diene, and the substituent is present at carbon atom 2 from left to right, so it will be 2-methyl-buta-1,3-diene. Alright, now let's take a look at this interesting example. All we see here are lines. There is no carbon, no hydrogen present here. So what is this structure? This is what we call a bond line diagram. You can know more about them in detail by watching my video on the bond line diagrams. But for now, all you need to know is that any end point is a carbon atom, and also anywhere two lines are meeting is a carbon atom. So I will just go ahead and mark all the carbon atoms. You can also see that there is a double bond present. So this is an alkene and it is represented using the bond line diagram. How can we write the name of this compound? The first thing to do is to find the parent chain. Can you take it as a challenge and identify the parent chain in this compound? Pause the video and do it yourself. Alright, let me draw the parent chain for you. The parent chain starts with this carbon and it can go like this. So this parent chain contains the double bond and it also has the most number of carbon atoms. You can count them. If you count from this end, it will be 1, 2, 3, 4. So the double bond is at carbon atom 4, 5, 6, 7, 8, 9 and 10. And if you count from the opposite direction, then the double bond will come at carbon atom 6. So therefore we will start naming from this direction. Now what are these groups over here? You can see that there are 2 carbon atoms here and 2 carbon atoms here. So what is the substituent that has 2 carbon atoms? It is an ethyl group. So there are 2 ethyl groups present here. One is at carbon atom 5 and other one is at carbon atom 6. Similarly, what is this substituent? It has only 1 carbon atom. So it's a methyl group. Alright, so we have everything to write our name now. There are 10 carbon atoms in the parent chain. So the name of this compound will be deca or dec. Then the position of the double bond is at carbon atom 4. So it will be 4 in. Now we have 2 substituents, ethyl groups at 5 and 6. So it will be 5,6 diethyl. And there is a methyl group at position 3. So it will be 3 methyl. When writing the name of the compound, we write alphabetically. So we will first write 5,6 diethyl, then 3 methyl, dec4-ene or deca4-ene. That is the name of this compound. Okay, another bond line diagram. Can you write the name of this compound? Pause the video and try it. Let's first identify all the carbon atoms. So we have a carbon atom here, then a carbon atom here, third carbon atom, 4, 5, 6, 7, 8, 9, 10. There is one carbon atom here, another carbon atom here, another carbon atom here, one carbon atom here, one carbon atom here, and one carbon atom here. Now can you identify the parent chain of this compound? When identifying the parent chain, our rule is to keep the double bond in the parent chain. So we can choose from here and continue moving along this line and then move like this. So both the double bonds are now part of the parent chain. So this is our parent chain. How many carbon atoms can you count in the parent chain? If you number from this side, it is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So there are 10 carbon atoms here. Now these substituents have 1 carbon atom each. So they are all methyl groups, and this substituent at carbon atom 4 has 2 carbons. So it's an ethyl group. And the other ones are methyl groups. This is also a methyl group. Okay. Now, if you number from this side, the first carbon-carbon double bond is at carbon atom 2 and the other carbon-carbon double bond is at 9. But if you number from the opposite side, then the first carbon-carbon double bond is at carbon 1 and the second double bond is at carbon number 8. So we get the lower number by moving from this direction, and thus we will write our names from moving from the right towards the left. So we have 10 carbon atoms in the parent chain. So it's a deca, then 1 and 8 diene. Now for the substituents, moving from the right to left, the ethyl group is at carbon atom 7. So it is 7 ethyl, and the methyl groups are at carbon number 2, 4, 5 and 6. So 2, 4, 5, 6. There are 4 methyl groups, so it will be tetramethyl. Name of the compound thus becomes 7-ethyl 2,4,5,6 tetramethyl deca 1,8 diene. Alright, enough about alkenes. Now let's talk about some alkynes. Look at the first compound and quickly identify the parent chain. Since there is no branching, so this is the parent chain. Now number the parent chain from left to right. The triple bond comes at carbon number 3, and from right to left the triple bond starts at carbon atom 2. So we will choose this direction. There are 5 carbon atoms in the parent chain, so it will become pent. Then position of the triple bond is at number 2, and for triple bond we write YN. So pent 2-ine. That is the name of this compound. Okay, look at this example. There is a triple bond here and also substituents are present. So identify the parent chain. The parent chain is this, because we want to keep the carbon-carbon triple bond in the parent chain. Then we have 2 methyl groups as substituents. Let's start numbering from left to right. We have 1, 2, 3, 4. So the triple bond is at carbon atom 3, but from right to left we have the carbon-carbon triple bond at carbon atom 1. So we will start following right to left in this example. So the name of this compound will be but 1-ine, and the methyl groups are present at carbon atom 3, so it is 3,3-dimethyl but 1-ine. Alright, let's look at this example. Now here we have both the triple bond as well as the double bond. So there is no branching, so that is the parent chain. Now which way will you number? Will you go from left to right and have the triple bond at carbon atom 1 and the double bond at carbon atom 4, or will you go from right to left and have the double bond at carbon atom 1 and the triple bond at carbon atom 4? Okay, so when naming we give the carbon-carbon double bond the lower number compared to the carbon-carbon triple bond. Therefore we will start naming from right to left. Thus the name of this compound will be pent, because there are 5 carbons in the parent chain. Then the double bond is at carbon atom 1, so it is 1-ene, and the triple bond is at carbon atom 4, so it is 4-ine. That is the name of this compound. Let's look at this example. Now here we have both the double bond and the triple bond. So we can see that the parent chain can be marked as this. Now there is a substituent CH3 group here. When you number the parent chain, if you go from left to right, you have first double bond at carbon 1, then second double bond at carbon 4, and a triple bond at carbon atom 6. If you go from right to left, you have the first triple bond at carbon atom 1, then a double bond at carbon atom 3, another double bond at carbon atom 6, and then 7 carbon atoms in total. So, which one will you choose? As the position of the double bond and the triple bond is same when comparing the left and the right, we will prefer the double bond. So we will start numbering from left to right. Alright? When the positions are the same, the preference is given to the double bond. So this compound has a substituent at carbon atom 3. So the name of this compound can start as 3-methyl. There are 7 carbon atoms in the parent chain, so it is hept. Then there is one double bond at carbon atom 1 and the other double bond at carbon atom 4. So 1,4-di-N, because there are 2 double bonds. Then at carbon atom 6 there is a triple bond. So 6-ine. 3-methyl hept 1,4-di-N 6-ine. That is the name of this compound. Alright, so we looked at a lot of examples with different variations, substituents, without substituents, double bond and triple bond both in the same compound. Write the structure of these molecules separately and try to name them once again by yourself and then compare with the answers. This way you will develop the muscle memory of writing the IUPAC names of alkenes and alkynes. I will see you in the next video.